All right, let's take a look at number 38 on AAMC Practice Test 3. This is in the second set of discrete questions. Radium-226 spontaneously decays to radon with the emission of an alpha particle and a gamma ray. If the speed of the alpha particle upon emission is 1.7 times 10 to the 7th meters per second, what is the recoil speed of the resultant radon nucleus? This question tests two MCAT subject areas. The first is the conservation of momentum, and the second is radioactive decay. Radioactive decay we only need for one part of this, and that is what is the weight of an alpha particle. The weight of an alpha particle is the same as that of a helium atom, and that is 4 AMUs with 2 protons and 2 neutrons. The crux of this problem, though, is conservation of momentum. And since we're told that initially the radium nucleus isn't moving, we know that the initial momentum of the entire nucleus is 0. So we're just going to picture this entire thing as the radium nucleus, and then afterwards this alpha particle here will leave the nucleus. So after the decay, we have an alpha particle with 4 AMUs and 2 protons. That leaves a radon nucleus with 222 AMUs. 226 minus 4 that decayed from it equals 222 AMUs. Now we just do a conservation of momentum problem. We say that P initial equals P final. And we're going to treat this decay as the reverse of a collision. So if it's the reverse of a collision, we look at it initially, and initially when it was together, it was stationary. If it was stationary, it had momentum of 0. So that was the initial. So what's the final? The final momentum is going to be the momentum of the alpha particle times the velocity of the alpha particle plus the momentum of the radon nucleus times the velocity of the radon nucleus. And that too is going to equal 0 due to conservation of momentum. Now we just have a plug and chug, as long as we remember that these two velocities will be going in opposite directions upon a decay. That gives us m alpha v alpha equals m radon v radon. And now we just plug and chug. We have 4 times 1.5 times 10 to the 7th. And that's going to equal 222 times the velocity of the radon, which gives us the velocity of the radon equals 6 times 10 to the 7th meters per second over 2 times 10 to the second, or just more than that, which gives us a little bit less than 3 times 10 to the 5th, or 2.7 times 10 to the 5th. And you want to get in the habit of doing this type of estimating, where you say, instead of actually dividing that out, you might just say it's going to be a little bit less than 6 divided by 2, because there was a little bit more than 2 to begin with. It was 222. Okay. That's it.